Okay, let's take a look at today's lesson. What we're going to be looking at are direction angles and direction cosines. So when we're in 3 dimensions, there's more than one way to place a vector. Just like when we're in 2 dimensions. You know, we can have a rectangular points for it, like say the vector is 1 2, that just means it terminates at location 1 2. We could also describe it with angle measures, and that's exactly what we're doing when we are in 3 dimensions here. We can take a vector in 3 space and we can describe its location by rectangular coordinates. 7, for example, we've done lots of these before. Like 7, -2, 3. Okay. Basically, that describes the location of the vector for us. It gives us the point of a terminal, basically the terminal part of the vector. So this would be in rectangular form. Well, there is also a need for a way to describe the location of vectors using angle measures as well. And that's what this lesson is about. How do we describe the location of a vector using angle measures? So there are 3 direction angles. So we're going to talk about direction angles first. And we're going to look at this diagram over here first. So there are 3 direction angles. The first one is alpha. It's a Greek letter alpha. Basically measures the angle between the x-axis and the vector. So that's what that angle is doing. Alpha, again, is measuring the angle between the x-axis and the vector itself. Then we have beta. Another Greek letter, beta. Beta is the angle measure from the y-axis to the vector. Okay, so see how we're kind of placing it in space? We're determining what the angle measure between the x-axis is, the y-axis is, and lastly, this is gamma. And this is describing or measuring the angle between the z-axis and the vector. So those 3 angle measures place the vector in space for us. Okay, so alpha, beta, and gamma will place that in space for us. So how do we find those? What do we do? So we have formulas, and that's where the direction cosines come in. We have formulas to be able to find those angles using cosine. And so this is a formula. These are formulas for the direction cosines. So let's talk about where that comes from. So I have a vector. It's basically written right here where v sub 1 is my x component, right? So if we wrote this in component form, I'd have v1, v2, v3. So either in ijk or in component form, those are they're constants, right? They're numbers that represent the x, y, and z position. So in order to find this angle measure alpha, what I would do is I would take this v1, whatever this number is, and I would make a fraction with it over the magnitude of my vector, the magnitude of this whole vector, and then I would do inverse cosine, and that would give me my angle alpha. And that's really all this is. The direction cosines are actually referring to these. When it asks for direction cosines, it's asking for these numbers right here. That's what's called your direction cosine. It doesn't really have the cosine attached to it. Basically what that's telling someone is this would be cosine 1, C1. This would be cosine 2 and cosine 3. So if I have cosine 1, then I know all I have to do is inverse cosine to get alpha. Okay, I'm giving you vocabulary words and talking about what those vocabulary words mean. If I have cosine 2, I would simply need to inverse cosine, and that would give me angle beta. And if I had this fraction, this relationship cosine 3, then I would simply have to do inverse cosine and get gamma. Okay, are we okay with those vocabulary words? So the direction cosines are these numbers right here, and the direction angles are these actual angle measures that measure the location of the vector in space using angles instead of rectangular coordinates. There's a special property associated with these, which is right here. So if you square, you do cosine squared of alpha plus cosine squared of beta plus cosine squared of gamma, you get 1. That's pretty cool. It's a property, a relationship that will allow us to find a missing angle if we have two. Let's say we're given alpha and beta. We would be able to find gamma using this relationship. So that's an important relationship to know. So just basically it gives a relationship between the three angles and allows you to some flexibility, or helps you find a missing angle. All right. Questions on the general concept? Okay, it definitely is a calculator lesson. I hope you have your calculators with you. Really not going to be able to do much unless you have a calculator, because these are not going to be unit circle values for the most part. So let's take a look at the first example. It's asking us to find the direction cosines and direction angles of this particular vector. So the formula that we got on the previous page, just to help you memorize it, let's kind of refer back to another formula that we are familiar with. Recall the formula for the angle between. All right, we dot the two vectors and then we do the magnitude of each. Just so that I'm hoping it will help you remember this formula, I'm going to take you through the first one using this formula. So basically what we're doing is we are dotting this with our vector I. Right, we want the x component is what we're looking for. So I'm going to use this formula, and I'm going to show you how this formula basically evaporates the formulas on the other page. The other page formulas weren't just made up. They're created from this formula that we already know. So let's say, so let's go ahead and dot. So v dot I. So v is 375. And vector I, that's the vector that's just exists in the x direction, would be 1, 0, 0. Okay, so if I do v dot I, you'll see when I dot these together, I simply get a 3. That's what would go here in the numerator. Then our old formula that we know, so I would do the magnitude of v, which would be what, 9 plus 49 plus 25. So the magnitude of v is the square root of 83. And then I would do magnitude of I, which is just 1. So you see I'm doing cosine of alpha would be the v dot I, which is 3, over the magnitude of v times the magnitude of I, which is simply root 83. And this is just that formula from the other page. It's just a formula, right? The formula from the other page tells us to take the x component and divide by the magnitude of the vector and then do inverse cosine on that. That's all we're doing. So I just wanted to show you how it's basically just a version of this formula that we already know. So you don't have new formulas to memorize. You just need to know how it's related. Okay, so what we would do is we put this in our calculator. We would do inverse cosine of 3 over root 83, and then our direction angle, so alpha is going to be 70.774 degrees. So then cosine of beta, we're going to go straight from the formulas on the other page instead of creating it the long way this way. So the formula tells us to take, for beta, we're going to take my y component, 7, put it over the magnitude. And then, so I do put in my calculator inverse cosine of 7 over root 83. And I get 39. So beta is 39.794 degrees. Then lastly, to find gamma, so cosine of gamma is going to be my z component, which is 5 over root 83. So gamma is going to be 56.718 degrees. So now let's go back up there and make sure we're answering the questions. They wanted us to find direction cosines. So I would just write that out. Cosine 1 was 3 over root 83. That's my direction cosine for my x component. Cosine 2 is 7 over root 83. And cosine 3 is 5 over root 83. This is what is called my direction cosines. Okay, that's what those are. The numbers are the direction cosines. Okay, the direction angles, so we did direction cosines. Direction angles are simply these things right here. Those are the direction angles. And now we've answered the two questions that they asked. Find the direction cosines and find the direction angles. Okay, are we okay with that? Okay. Let's look at our second example. On here, they want us to find the direction cosines and the direction angles of this other vector. And then, lastly, use the result to write a unit vector in the direction of v. Okay, well, let's start out with the magnitude of v. So that's going to be 13 squared plus 6 squared plus 18 squared. And so that's the square root of 529, which just so happens to be 23. Okay. So let's work on direction angles and direction cosines. So cosine of alpha is going to be 13 over 23. So I'm going to do the inverse cosine of 13 over 23 in my calculator. And my angle alpha is going to be 55.583. 55.583 degrees. So let's do cosine beta. My C2, or my second direction cosine, is negative 6 over 23. Be sure that you put that in as a negative. Let's think about what that means. Which quadrant is cosine negative in? The second and third, right? The second quadrant. So basically, this is going to give me an obtuse angle. Putting in that negative 6 over 23 is going to give me an obtuse angle. If I forget to put the negative in, then it's not going to give me the obtuse angle. It's going to give me the acute angle that's related to that. So just be cautious and be sure that if it has a negative, that you're sure to enter it. So beta is 105.122 degrees. And then cosine of gamma, 18 over 23. So again, doing inverse cosine in my calculator, 18/23. Gamma is 38.499 degrees. Okay, so my direction cosines are these right here. Right, my direction angles are these. But that's not really what they want, right? They want us to write a unit vector in the direction of v. Let's talk about what a unit vector is. We've had some confusion over that. Now we have the, unit vectors. So I have I there, j is there, and k is this way, right? Those are the main unit vectors, right? That's I, j, and k. They just go one direction, either x, y, or z directions. But there can be other unit vectors besides that. Those are not the only unit vectors. Unit vector means that the magnitude is 1. So I can have other vectors with a magnitude of 1 really anywhere, can't I? I mean, it doesn't have to be I, j, or k. So we typically would notate that with a u for unit vector. That's what we would normally say, unit vector. And it sounds like this is going to be really hard, but think about if I use that property from the other page, cosine squared theta plus cosine squared beta plus cosine squared gamma. What does that give me? 1. Okay, these will give me a magnitude of 1. Right, so that is my unit vector. My unit vector is 13 over 23i minus 6 over 23j plus 18 over 23k. So that is the unit vector. And what it means by in the direction of v is, notice these are the direction cosines of v. Right? These are going to point us in the direction that v is pointing in. We simply have normalized it or made it the unit vector instead. Are we okay with that? Okay. And the last one, we basically are given alpha and beta, and we're asked to find gamma. And for that, we need to use the property that I showed you on the other page, right? The cosine squared, that property. So if I have cosine squared 152 degrees plus cosine squared 73 degrees plus, and C3, I don't even know what that is, C3 squared. We're just going to write it as C3 squared. That's going to equal 1. So let's solve for C3 squared. So I have C3 squared equals 1 minus cosine squared of 152 degrees minus cosine squared of 73 degrees. Okay. So I enter that in my calculator, 1 minus cosine squared 152 minus cosine squared 73, and I get C3 squared is 0.1349. Okay, then I square root both sides. Right, so C3 is going to be a plus or minus. I'm square rooting both sides, so this yields a plus or minus. A plus or minus 0.3673. And you know, I would leave that in my calculator, all those decimals. So what does this tell me? This tells me I have a positive and a negative. That's just the cosine, right? That's the direction cosine. That's not the direction angle. What do I have to do to get this into a direction angle? Well, I would have to do inverse cosine of this, right? When I do inverse cosine of the positive one, I'm going to get an acute angle. And when I do inverse cosine of the negative one, I'm going to get an obtuse angle. I have two options. We will have two options for gamma, not just one. Okay? So let's do that. So gamma could be, when I do inverse cosine of the positive 0.3673, I get 68.449 degrees, or gamma could be 111 when I do the negative, inverse cosine of the negative 0.3673, 111.550 degrees. And so that's what gamma could be, either of those. You should get two options typically, just like that. Okay, how is our lesson on direction angles and direction cosines? Are we okay?